All right, in problem 11, we are trying to find the square root of all of this information in here. So first the 50, then the x to the 7th power, then the y to the 9th power. So it helps to know your perfect squares in this case, okay? And once again, square root is simply the length of one side of a square. Of course, that's a jacked up square, but hey, you know what I mean. You know what I mean. Okay, so if I have a length of side S, then obviously all the sides are the same length, S all the way around. Okay, and if I want to find the area of this square, I simply multiply side times side, which is side squared, or again, length times width. So it helps to know your perfect squares once again. When I square 1, which is 1 times 1, I get 1. Okay. When I square 2, I get 4. When I square 3, 9. When I square 4, I get 16. And when I square 5, I get 25. So just the inverse of that is true. The square root of 1 is 1. The square root of 4 is 2. Square root of 9 is 3. And the square root of 16, 4. Square root of 25 is 5. Well, I bring that up, and of course it goes so on, for it's the same for 6, 7, 8, 9, etc. Because we're going to have to factor out this 50. So we start with the square root of 50. Let's just start with that first term. The square root of 50 is the same as, if I look on my list here of perfect squares, I'm going down here and I see 25 is on there. That's the highest perfect square. I just want to factor out the highest or the greatest perfect square of the factors. So what is 25 goes into 50 2 times. So, and 2 is not a perfect square if you look here. It's a square root, but it's not a perfect square. So it's the same as square root of 25 times the square root of 2. That's the same as the square root of 50. So we all know that when we simplify, we take the square root of 25, we get 5. So 5, and then the square root of 2 is not a perfect square, so we just leave it underneath the radical. Okay, so 5 root 2 takes care of the 50. Okay, that's the 50 part taken care of. Now x to the 7th power, there's no way you can really, there's no factors of 7 that are perfect squares, and 7 itself is not a perfect square, so we just leave it x to the 7th power. Now, 9, this y to the 9th, 9, on the other hand, is a perfect square. It's a perfect square because the square root of 9 is 3. So I could actually bring y outside of the radical, okay? Because the square root of y to the 9th power is simply y to the 3rd power. Because 3 times 3 is 9, right? So if I take the square root of y to the 9th, I should get y to the 3rd. So my final answer, when I arrange this correctly, sorry about that. When I arrange this correctly, the final answer is going to be 5 y to the 3rd, because y is outside of the radical now. And then multiply that times the square root of 2x to the 7th. That should be your final answer. Look that up and make sure that is correct.